Okay, guys, here we go. This is section 4.6, and we're talking about inverse trig functions. And so we've graphed these functions. We know a little bit about it. We know something about the unit circle. I think our biggest problem that we're going to have with working with this is trying to put all of this together, inverse trig functions. And we'll see two types of listings of, we'll see, sorry, I gotta get myself to this spot. There we go. And so you'll see it written as like sine, inverse sine, like this, like you see on the calculator, or we can also call it arc sine. So that's the first thing. Arc sine, arc cosine, arc tan, and those are the things we're going to work with. And so when we're talking about the sine of an angle, remember back when we were just looking at triangles, right? Just looking at those right triangles, and we were looking at we're looking at an angle here. We had opposite, and we had adjacent, and then we said, the sine of the angle, sine theta, is going to be opposite over hypotenuse, right? And so now we're talking about, inverse sine. So what it says is that the inverse sine of opposite over hypotenuse is going to give me the angle. So I'm going looking for an angle, but I'm not looking for a degree measure. Before, in other classes, maybe your physics class, you were looking for an actual angle measure. And remember, now we're talking about the unit circle. So why is this like that? I want that. Okay, so we were talking about the unit circle. I don't like that at all. Let's undo that. Boy, you suck. So we were talking about the unit circle. It's close enough to a circle for me. And then we were talking about how to find values. And so when we started talking about the unit circle, we were talking about radians. So we're talking about 2 pi, pi over 2, etc., etc. And then there were values that we had where the x value was we said it was this 30 degrees, so this is root 3 over 2 and 1/2. Right? And so you need to have your unit circle handy to do the work for this section. So if you don't have a unit circle, pull up a filled out unit circle if you don't have it with you. And then we're going to start talking about all this stuff. So if we're talking about opposite over hypotenuse, and we're talking about on the unit circle, and just say for instance this happens to be 1/2. Maybe this is 1/2. Well, now we're going to talk about the arc sine of 1/2, and we say, oh well, I know that because this spot right here, this angle in radians is what is that? Pi over 6, right? My 30-degree angle is pi over 6. So I'm going backward to find my radian degree measure, right? So that's what arc sine and arc cosine and arc tan are, right? And so we're going to be going through a whole lot of stuff to figure these answers. Just let me get rid of this, and we'll start looking at it. Now, we do have a problem. There is a problem. Our big problem is this. When we talk about an inverse function, remember we said an inverse function doesn't exist if it doesn't pass you can't have an inverse function if it can't pass the horizontal line test. So when we were in here and we were talking about quadratics, there's no inverse function. We can't draw an inverse function of the quadratic because, hey, it doesn't pass the horizontal line test. Well, hey, you say, hey, Mr. Sokol, what is it? Didn't you just say that you can't have an inverse function if it doesn't pass the horizontal line test? And so what I'm going to do is I'm going to show you what we do to show inverse sine. All right, so we have to restrict because the sine function goes up and down, right? And it doesn't pass that horizontal line test. Look here. I'm going to change the color so it's a little bit darker so you can see it. If I draw a horizontal line, sorry about that horizontal line, but you can see once it starts to repeat, all those sine and all those y values on the unit circle, after a certain point, they start to repeat. So we can't have them. We can't have it work that way. But we can restrict our sine function to a portion that does not repeat. We get it to a spot where it doesn't repeat. And that spot is from pi over 2 to 3 pi over 4 if we look at it on the circle, but we can't use, that. So we're gonna say negative pi over 2. Okay, and so, we have half a circle to work with, and I'm going to show you what that looks like. So we're going to use sine values, inverse sine values, for all of this part of the circle. So that just for quadrants 1, oops, I've got to be on this layer, just for quadrants 1 and quadrant 4, okay? And the same thing I'm going to tell you later on, it's going to hold true for tangent as well. And I use the same picture for it. I'm going to cross this out and write tan on it. But that's the idea. So we talk about this inverse function, and look, they just sort of go in opposite directions. And how do you find the inverse, remember, we swap x's, x and y to find our inverse. Remember, that's how we did it. That's how we found inverse functions. We swapped x's and y's. And so if we look here, the domain are x's, pi over 2, negative pi over 2 to pi over 2. So when we draw it here, look at how it's negative pi over 2. These are our y's and pi over 2. And then our x's are 1 and negative 1. Okay, and so that's what it looks like. You'll notice, I'm going to talk about this later, that these, the sine function itself, they have endpoints. They can't go past this, or else they're going to, start. It's no longer going to be a function because this is going to start bending back around and it won't cross. It won't be a function because it won't pass the vertical line test. And so I know this is a lot of material I'm throwing at you right now. Okay. So let's move on and let's start talking about how to find inverse sine values. Maybe if I get rid of that guy and that guy, and we'll move to this layer here because now we're going to start looking at what those values are on the unit circle, right? So let's just think about it. I'm going to show you that we cheated, right? We cheat. Legal cheating, but let's look at this first one. I'm just going to draw a circle over here just to remind you of the unit circle. Right, so we're going to look for the arc sine of root 3 over 2. Well, the sine of root 3 over 2, you know, let's think of a spot between here and here, and look on your unit circle, and where is it that the y value in the coordinate pairs is root 3 over 2. So, you know, I'm sort of pointing you in the right direction. I'm pointing you up here, right? Because we have a half, we have root 2 over 2, and then root 3 over 2, and that's right here at pi over 3. So the arc sine of root 3 over 2 is pi over 3. We're looking for the angle in radians. Okay? Well, let's look at this guy right here. How am I able to go negative 2 pi when I'm restricted, right? Remember, we're restricted to 1, 1, and negative 1. And we're restricted to pi over 2 and negative pi over 2 when we're talking about our inverse function. So we're not allowed to go past that pi over 2. So this does not exist as an inverse function. So we can't find this. This doesn't exist. All right, and the book will trick you a bunch of times. You know that I'm going to show you that the next time, even when we look at the cosine, we're going to see that that's exactly the case. So here's the cosine. It is also restricted. The only thing that's different about cosine is that it's restricted from 0 to pi radians, okay? And so we show that on our number line, it still has a range of 1 to 1 before it starts to repeat, but so we still use negative 1 to positive 1, but right here on the x-axis, before we swap, we go from 0 to pi, and that looks like this guy. So we're only taking x values in quadrants 1. Oops, I forgot to jump over here. In quadrants 1. Hey, I forgot to go to here. In quadrants 1 and 2. Boy, howdy. What am I doing today? Anyway, so now that we've seen this and we have our unit circle handy, and I hope you have your unit circle handy, I'm going to move on. I don't have my unit circle handy. I'm just relying on my memory, because, you know, that's what old farts do. They memorize stuff, and I'm gonna have to move this up. Got a lot more layers to deal with, so just bear with me one quick second while I do this. Here is our problem. So cosine, arc cosine, what is the angle? Basically it says, what is the angle when the cosine is negative, when the x value is negative root 3 over 2. So we have, you know, that circle. I'll do this circle again. God, I hope I'm on it. I'm not on it. That's why I said you can't do it. Sometimes I am almost smart. So remember, it says that we can only use values from the top. If I do that again, it's going to be really goofy looking. Get rid of that. So we can only use the top half, right? So cosine root 3 over 2 is right here, positive root 3 over 2. So way over here is negative root 3 over 2, right? And this is pi over 6. So way over here, because we're almost at 180, is 5 pi over 6. And you would have a much easier time because you actually have the unit circle sitting in front of you. And if you do not have the unit circle sitting in front of you, you're going to have a devil of a time figuring these things out. Because if you put it in the calculator, it's not going to give you an answer in terms of pi. It's going to give you a decimal answer, right? This is going to be, I don't know what 5 times, it's like 15 and a half divided by 6. I don't know what that is off the top of my head, but hey, you're going to have some weird answer, and you're going to write that down, and I'm going to say, no, you need to write your answer down in radians, which includes pi. So they tried to trick you again. Look at this ugly guy right there. What is the arc cosine of 2.5? And remember, we're only allowed to go from 0 to 1. So, this again, you are the devil. We hate you. That does not exist, right? You can d-any it, and we can move on to the next part. So I hope you understand this is the very beginnings of inverse functions. It's not tremendously difficult. It just gets to be a little bit of repetition if you understand where these restricted functions are, okay? You'll notice that the y's and you remember that the y's in a tangent function, the range is infinite. So that holds true that when you talk about the inverse function, the domain will be infinite, and we're going to carry these asymptotes and just flip it, right? So we swap our x's and our y's, and our domain here becomes our range here, and we'll still be working with this same type of deal here. And then the good news is, if our domain originally was negative pi over 2 to pi over 2, hey, that's just like sine, right? Inverse sine. It was restricted to negative pi over 2 and pi over 2. So you're going to have answers. You're going to pull your answers from quadrants 1 and 4 again. Okay, so tan, and this is when I told you I was going to cross this out and write tan over it. Here it is. Just like sine, we're going to just find inverse tan that way. All right, so now we know where we have to find these values on the unit circle, and then we can just find the inverse tan. So let me get rid of this and get rid of this and give you the problem that goes with it. Here's our problem. What is the inverse tan of negative 1? Well, I only chose this because I knew it was an easy get, especially for you guys. If you look at tangent, remember tan is equal to sine over cosine. So where on the unit circle would we find negative 1 when we have sine over cosine? If y over x is 1, but we wanted it to be negative, there's only one spot in quadrant, and it's going to be in quadrant 4, and it's going to be at negative pi over 4, right? Because at pi over 4, right, we have negative root 2 over 2 and positive root 2 over 2. Isn't that the coordinate pair at pi over 4? And so sine over cosine gives me negative 1, this is where, this is the radian angle where we find inverse tangent, you know. And that, just like before, they give you one that doesn't exist because they give you an inverse tangent where it's an undefined domain. So I didn't want to give you that one. It got kind of boring. So just to recap, here we go. Inverse sine is bounded between pi over 2 and negative pi over 2. Same thing with the tangent. The range, the domain for both the sine and cosine functions, -1 to 1, and they are bounded. You know, they don't continue. They have actual endpoints. Last but not least, you should get used to looking at these signs, these little symbols in here. And then the last thing is tangent has an infinite range, infinite domain. Oh my God, I said it again. Has an infinite domain. It says it right here, for goodness sake, Sokol. It says the range is negative pi over 2 and to pi over 2, but the domain is infinite. Sorry about the stupid voice there. But that's the very beginning. And I'm going to stop the video now. And you can do some of the work and then move on to the second page of work where all the fun starts. Because we're actually going to draw some things to get our answers. But that's basically it. And I'm not going to show you any of this nonsense anymore. I may, have a little unit circle in the corner, or I may not. It may not be big enough for us to get the answers. So thank you, and I'll see you in a few seconds.